Welcome back, AP Calculus AB, to our AP Targeted Review. You want to be very careful that you're on the right video for this review because there are actually two wildcard question review videos. This one is AB, the other one will say BC, and you should be doing the one that is relevant to your current content area. Alright, with that out of the way, let's get to it. What the heck are these wildcard questions? Well, the last couple years, College Board has kind of just thrown this free response at you, one of the 6 free responses that just kind of has a myriad, a variety of different topics and problems on here. They don't fit nicely into any of my categories, so I just made a wildcard category. Maybe it's like the potpourri category on Jeopardy! So what are some different types of questions that might show up on these wildcard FRQs? Well, a lot of times they have general derivative or antiderivative questions. What's the derivative of this? What's the antiderivative of this? So they'll often ask you to write the equation of a tangent line, and sometimes they'll have some theorems on there. We're actually not going to focus too much on the theorems on this because I think I cover all of the other theorems at some point on pretty relevant videos here, and some recent ones too. So when you see limits, you'll see some theorems, and tabular data, you'll see some theorems. So we're going to really stick to these 3, though there might be a theorem or 2 that rears its ugly head. These questions tend to not be on the calculator active section, so it's either going to be question 3, 4, 5, or 6. And they're not calculator active because they're testing you on some general rules, and they worry that you could do that with a calculator. So without further ado, let's get started. As always, you are going to want to work ahead, and then if you get stuck, you'll come back. There's no reason you'll need to spend 45, 50, or 60 minutes on this video when you can do all of this in 20 and then just check your answers faster. So we're going to start with 2016 question 6. I'll give you a chance to do it, and then we'll come back together. Ready, set, go. Alrighty, we have the functions f and g that have continuous second derivatives. That's going to tell us that the f and f prime and g prime are also continuous. So let's go ahead and get started. Let k of x equal f of g of x, a function composition. Write an equation for the line tangent to the graph of k at x equals 3. We've done this before, so we know that t of x is going to be found by k prime evaluated at 3 times x minus 3 plus k of 3. Alright, let's start with, I guess we should probably start with k of 3, a little bit easier, right? So k of 3 is f of g of 3. F of, let's see, g of 3 is 6, very nice. And then f of 6 is 4, awesome. We also need k prime of 3, but before we can find k prime of 3, we should probably find k prime of x. That makes sense, I think. And that is the derivative of k. This is our chain rule. F prime, keep the inside the same, but then we multiply by the derivative of the inside, which is g prime of x. And that tells us that k prime of 3, notice I'm using an arrow to connect these. We are certainly not going to say equals here. You would lose a point for doing that. This is an equation. This is a value. Equations and values are seldom equal. An arrow, or just write nothing if you'd like, but make sure you don't connect those with an equal sign. K prime of 3 is f prime of g of 3 times g prime of 3. I always like to do the primes at the same time, so I'll do g of 3, which we did earlier. That's 6, isn't it? So f prime of 6 times g prime of 3. All right, f prime of 6 is 5, and g prime of 3 is 2. So we have 5 and 2, which gives us 10. Excellent. Let's finish off our tangent line then. T of x equals k prime of 3, which was 10, times x minus 3 plus k of 3, which is 4. Awesome. Notice that I'm not boxing my answer. It's a good habit to probably not box your answer. The question might be why. Well, I can give you an example on this one pretty easily. They said write the equation for the line tangent to the graph of k. What if they had said write the slope for the line? And I'll show you what that means. Write the slope for the line tangent to the graph of k at x equals 3. Well, the slope of the line tangent is actually k prime of 3. This is the answer if that had said 10. But if you didn't realize that and you saw a tangent line, you went into, automatic mode and you wrote a tangent line like this, but you left this problem exactly as I've written it here, you would get full points because you've shown that the slope of the tangent is 10. Cool, you wrote some extra information down here that's not relevant, but that's okay. However, if you had written this and you had boxed this tangent line, then you would lose the point because they said write the slope, and by boxing the answer, you're telling them, I think this is the slope. But that's not the slope. That's the entire equation for the tangent line. So we want to make sure that we maybe don't box an answer if we're not quite sure. There's nothing wrong with boxing an answer. As a grader, I like it when you box your answers. But if you really want to play it safe, avoid boxing those answers. All right, part B. Let h of x be defined below. Use h of x to find h prime of 1. Cool. This looks like another derivative problem. So we're going to find h prime of x first. This equation is just a quotient, so I think we need the quotient rule. This won't be bad. H prime of x, we do the derivative of the top first. Keep the bottom the same. Subtract, right? The product rule has the plus, the quotient rule does not. Keep the top the same times the derivative of the bottom, and then all divided by the bottom squared. Okay, so then I think we need h prime of 1. And that's going to be g prime of 1, obviously f of 1 minus g of 1 times f prime of 1, all divided by f of 1 squared. All right, as we work to the right, g prime of 1, I think we're going to just have to do a bunch of this up here. G prime of 1 is 8. And then f of 1, I always use parentheses here, so that way you don't drop a negative anywhere. Sometimes if you drop the parentheses, then it means something different than what you were trying to convey, and bad things happen. G of 1 is 2, and f prime of 1 looks to be 3, all over f of 1, which we already found is negative 6. Parentheses are very important there. If you write negative 6 squared, you're wrong. You need to put negative 6 squared. Negative 6 squared means do 6 squared and then make it negative. So be very careful there. And then I'm going to stop. That's it. The end. We have the answer. Don't even think about simplifying something like this. I see so many students who simplify this complicated fraction, make a mistake with a negative or with a square or something, and they end up getting the wrong answer. This is worth full points, but if you simplify down and make a mistake, then you'll lose the point for the answer, and then you'll be sad. All right, part C. Evaluate the following integral. Okay, well, there are two ways to evaluate a definite integral. One way is to use the definition that it measures the area between the graph and the x-axis. But I don't have the graph of f double prime of 2x, so I don't think we're going to do that. Instead, we need to use our fundamental theorem of calculus. Shouldn't be too awful. Fundamental theorem, we do the antiderivative of f double prime, that's f prime. And then let's just think for a second that the antiderivative is f prime of 2x. I'm going to do a quick check over here. Maybe that's right, maybe it's not. So I'm just going to do ddx of f prime of 2x. Well, it becomes f double prime of 2x. Oh, don't forget the chain rule, times an extra 2. And I don't see an extra 2 in the original problem, so something must have canceled that out. That's going to be a 1/2. Your teacher might show you how to do this with a u substitution as well. It works, but I find a problem that's this quick is much faster to do without a u substitution. I'm also going to go ahead and cross this out because it's not really relevant to the problem. It was just me checking my work. So by crossing it out, I can still see it, but as a grader, we can't read anything there. Right? Again, it wouldn't count against you, but it's extra. You don't need it on the problem. No reason to keep it in. So then from 1 to 3. Fundamental theorem. I always like to use a big set of parentheses for each set of the fundamental theorem. So the first part is substituting in the top limit, 3. So 1/2 times f prime of, we can do 2 times 3, I think. That's 6. There we go. And then close that in parentheses. So the first value plugged in is going to be in parentheses minus, and then the second one's also going to be in parentheses. I find if students forget to put parentheses on here, then they might run afoul of this negative not being correctly distributed, so on and so forth. So sometimes students will say, well, can we stop here? You were able to stop early up above. Not quite yet, because the rule for stopping early is this needs to be something you can plug into just a basic, let's say a scientific calculator, those blue ones that you use in geometry. And you can't type in f prime into those blue calculators. So we do need to go one step further. Nothing too bad. I'll keep the parentheses again. 1/2 f prime of 6 and f prime of 2. F prime of 6, f prime of 2. 5 and negative 2. I think I can remember that. 5. And notice I'm using parentheses here, especially with that negative 2. I don't want to show something different than what we meant. And then that's it. Now we can stop. That's something you can type into a calculator. You can box it if you'd like, but I'm not going to simplify. All right. That was pretty easy, I think, right? We just kind of flew through that. Nothing too terrible. One of those wildcard questions. Let's try another. That was from 2016. Here comes 2017. This problem is interesting. It gives us 3 different functions presented in 3 different ways. The first function is f of x and is given like so. The second function is g of x and g prime. So f of x was given as an equation. G and g prime are given tabularly as in a table. And then we also have the graph of h, which is given as, of course, a graph. All right, let's begin. Find the slope of the line tangent to the graph of f at x equals pi. All right, well, let's pick this out. Remember, this is a calculus class. You need to be doing one of 3 things when you start pretty much every problem. You need to be taking a derivative, or an antiderivative, an integral, right? Using a limit, or the fourth thing is referencing a theorem. But I think it's not a theorem here. They say slope. We need to know that's the derivative, so really they want the derivative of f at pi. So translating that, doesn't that mean f prime of pi? I probably should have put that lower down because we can't find f prime of pi yet. That means evaluate or plug in pi into the equation called f prime. In order to do that, we need to find f prime of x. We need to actually find the equation. So we have this guy up here. We need to take its derivative. So we do the derivative of cosine. That's negative sine. Keep the inside the same. Chain rule. Plus e to any power is always itself. But then we need to multiply by the derivative of that power, which is cosine. Very nice. And then we go further. F prime of pi. Well, that's easy. Negative sine of 2 pi times 2 plus e to the sine of pi times cosine of pi. And then, keeping with our theme of today, do I need to reduce this? Well, actually, no. This is something you can type into pretty much any basic scientific calculator. They have trig functions on there. They have e, right? This is a numeric answer. It's a value. And so you can stop. However, I am going to leave myself space because it might be helpful at some point to come back and figure out the value of this answer. And so we'll leave a little space just in case. But yeah, that you'd get full credit for that. All right, let's continue on. Let k be a function defined by k of x equals h of f of x. Find k prime of pi. Okay, well, k prime of pi is going to be down here. We probably need k prime of x, though. That's nothing bad. Chain rule, we've done one of these earlier. H prime, derivative of the outside, keep the inside the same, times the derivative of the inside. So k prime of pi. Well, this is going to be h prime of f of pi times f prime of pi. All right. Moving on through, we need to figure out these values. Well, I know f prime of pi. That's this monstrosity up here. So someone might say, well, wait, can you just replace f prime of pi with all of that? Sure you can. There's nothing wrong. You get full credit. However, in order to save some space, I will actually evaluate this. Let's see what we get here. Sine of 2 pi, an even multiple for sine is going to be 0. So this whole thing becomes 0. Nothing bad there. Sine of pi is also 0. So really this is e to the 0th, and cosine of pi is negative 1. So I'm looking anything to the 0th is 1 times negative 1. I'm getting negative 1 as an answer. All right, so that's not bad. So we find h prime of something. We'll come back to that. And f prime of pi was negative 1. We did that up above. I'll do it in red so we can keep track. How are we going to find f of pi? Well, that's not too terrible, I think. F of pi is just the original equation, right? The original equation, cosine of 2x plus e to the sine of x. So cosine of 2 pi plus e to the sine of pi. Let's make sure I wrote that correctly. Just use this. Yeah, that looks just fine. So again, if you didn't want to evaluate all this out, you could just put this like so. But they are clever here. You're going to run into a bit of an issue. And the issue is we're going to have to find h prime of this. And so you'll actually need to know the value to substitute it into h prime because h prime is a graph. So we should probably determine the value of this answer. Cosine of that 2 pi is going to be 1. And then e to the 0th, 1 plus 1 is 2. Okay, finishing this off, we need to determine the value of h prime of 2. This is the graph of h. H prime then, and I'll write this up here, is going to tell us about the slopes of this graph. So here's 2, this point. Well, we can write this in two different ways. We might need them at some point. Let's look and compare h of 2 and h prime of 2. H of 2 is the actual y value at this point. Notice that we're going down 1 over 3. That means if we partition this line, we're going down in thirds. 1/3, 2/3, 3/3. So it looks to me like h of 2 is negative 2/3. H prime of 2, though, is just the slope of this line, and the nice part is a line has a constant slope. Any 2 points, if you can find the slope, is the same as the slope at any single point, and we already just said it's down 1 over 3, so the slope is negative 1/3. H prime of 2, negative 1/3, so we have negative 1/3 times negative 1, which is positive 1/3. All right, now sometimes the question comes up, well, wait, what if I simplified this down and I got it wrong and I said that this was positive 1? Well, that's okay. You would definitely lose a point on part A, but if you said that was positive 1 and you continued to use positive 1 here, you're fine. You would get the wrong answer, but you would get 100% points on part B. Now, there is a bit of a caveat, a bit of an exception here, and the exception is if this answer makes everything else too simple, then you will not continue to get points. For example, if you got that this was 0 and then used 0 down here, 0 would cancel everything out. You wouldn't even have to find h prime of 2, and so you would probably not receive any points for part B. So if you do make a mistake on part A and it makes everything else too simple, then you may not get those carryover points, that double jeopardy status. But if you miss just a sign or get a different number, you'd be totally fine on part B. Okay, part C. Let m be the function defined there. Find m prime of 2. You see what I mean about these wildcard questions? They're really just testing you on your derivative and integral skills, so it's nothing too terrible. This one we have two functions connected by multiplication, which is clearly the product rule. The derivative of g is g prime, but we kept the inside the same, so we better multiply by the derivative of the inside. Then, and I'm going to just do a big set of parentheses so it's a little overkill, we keep the second one the same. Product rule has a plus, keep the first one the same, and then the derivative of the second is here. Now we need to find m prime of 2. All right, and we're going to do a little bit of cleaning up here. So this becomes g prime, we're substituting in 2. Negative 2 times 2 is 4, and then times negative 2 on the outside. This is h of 2. This is g of negative 4, and then this is h prime of 2. All right, we can go through and hopefully use a few things that we've done earlier. For example, we saw h of 2 was negative 2/3, and we also saw h prime of 2 was negative 1/3. G of negative 4, I think we have a chart for that, a table, don't we? G of negative 4 is 5, so that's not bad. Okay, and then g prime of 4 times negative 2. We'll try to do both. G prime of 4 is negative 1. Negative 1 times negative 2 is positive 2. And I'm done. I'm not going any further. This is the answer. If you clean it up, it does come out to be a nice integer, but why bother, right? This is a timed test. If at the very end you want to go back through and very carefully check your work and simplify, okay, but I still don't recommend it because this is right, and if you simplify and make a mistake, you lose a point. Part D. Is there a number C? As soon as I see that, I'm already thinking this has got to be a theorem. Is there a number C in the closed interval such that g prime of C equals -4? Justify your answer. Well, there are two ways to go about this, and I'm going to show you both of them. One of them could be the IVT, and one of them could be the MVT. We should know the setups for both of these at this point. The IVT talks about the same function that's given. So g prime of C equals -4. The IVT says, well, let's find g prime of -5 and also g prime of -3. And we're going to hope that -4 is in between there. The MVT says, let's use one function above, let's use g, and let's find the average rate of change, the slope of the secant. And so we'd find g of -5 minus g of -3 over -5 minus -3. And we're going to hope that the answer is -4. So let's do the IVT first because I think that's less work. -5 and -3. So we have -5 and -3. That's -3 and 4. Is -4 between those? No, it's not. That's a real bummer. -4 is not in between. We can't use the IVT here. I'm just going to cross it off so we don't get confused. Going to be the MVT. Fingers crossed. So, -5, -3. That's 10 and 2. So we end up with 10 minus 2 over -5 plus 3. This is 8 over -2. Haha, -4. All right. We're doing pretty well so far. How do we finish this off? Well, we know this is going to talk about differentiability and continuity. The MVT has all that stuff in it. So differentiability and continuity. So let's take a look back up here. G is a differentiable function. Does that mean G is also continuous? Yes, it does, but we do need to state that. So this is going to get a little bit wordy, and I'm going to probably have to use a couple different things here, so a couple different spaces. So let's get started. As G is continuous, as G is differentiable, G is also continuous. There we go. That's that first part. Okay, so here we go. As G is continuous on -5, the closed interval, and G is differentiable on the open interval, and the average rate of change on -5 to 3 is -4, then the MVT guarantees the rest of this, right? So I'm going to write it all out. I'm not going to slack it all on this one like I did throughout the year. Guarantees there is a number C on -5 to -3. That wasn't great. There we go. Such that G prime of C equals -4. Whew. Definitely a bit of writing there. Should usually be able to do this in one sentence. I needed two because I needed to establish the link between differentiability and continuity. It is not okay to say as G is differentiable and continuous. You need to explain why G is continuous. All right, let's move on. This, I think, is our last one. Very exciting. So our last question comes from 2014. I tried to keep these fairly recent. Again, no calculator. We are given our values in a table. Let's see what we can do. So find the x-coordinate of each relative min from -2 to 3. Well, they've actually, so we should backtrack. To find relative mins, what do? Well, we start with finding our critical points. And so we should set f prime of x equal to 0, or determine when f prime of x does not exist. And what are our answers here? Well, we look at f prime and we can look straight across here, and I see, I think, two critical points. So it looks like -1 and 1 are what cause f prime to be 0. Okay, and then you can make a sign chart here. That's normally what I do for a relative min. They've really already made a sign chart for us up here, but I'll do my own because why not? So we have this. We're going from -2 to 3. We had 2 critical points. Remember, these critical points cause the first derivative to become 0. And then what goes in the middle? Well, from -2 to -1, we see negative, then positive. So negative, negative, positive. Therefore, the original graph f, I'll keep this in red, will decrease and then increase. All right, we want each relative min. I only see one relative min here at 1. So we'd say x equals 1 is the only relative min because x equals 1 is the only location where, well, what happens here? Read your sign chart. F prime changes from negative to positive. Okay, don't make anything too difficult here. So the only location where f prime of x changes from negative to positive. The end. Moving on. Explain why there must be a value c such that f double prime equals 0. Okay, well, same thing as before. You could try the IVT. In order to do the IVT, you'd have to use f double prime. The IVT guarantees something about the function that's given, so we'd have to be able to find f double prime of -1 and also f double prime of 1. However, it looks to me like the issue here is there is no f double prime function. Probably should have done a different color, and so it's certainly not the IVT. Therefore, try that MVT. Okay, and we try again. Now they're asking about f double prime. So in order to use our slope formula, we don't want to do f of 1 minus f of -1 over 1 minus -1. This is the slope formula using f, so this will guarantee something about f prime. We want to guarantee something about f double prime, so we need primes in here. This is the slope formula with f prime, or the average rate of change, or the slope of the secant line. Let's work this out. F prime of 1 and -1 are both 0. And this becomes 1 plus 1, which is 2, and so we end up with 0. These match, which they need to in order to use the MVT. Let's take a look. What has to happen for the MVT? Well, we can start writing our sentences, and then we can maybe fill in the rest after. So, as f prime is continuous on -1 to 1 and differentiable on -1 to 1, closed and open. Now wait, is f prime continuous and differentiable? Let's take a look. Twice differentiable functions, so f is and f prime and f double prime are all differentiable. I don't see anything about continuity. We need that extra sentence that we did before, right? So something like this. As f prime is differentiable, then f prime is also continuous. Okay, they were real sticklers for that last year. Will they be every year? Maybe not, but it's probably a good thing to put. All right, so as f prime blah, 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 and what is this? Oh, this is the average rate of change, or the slope of the secant line, but I like average rate of change. So, and the average rate of change on -1 to 1, probably closed, so it doesn't matter, is 0, then the MVT, and now we're just going to rewrite what was here. The MVT explains why there must be a value c for -1 less than c less than 1, such that f double prime of c equals 0. Bam. Okay. And maybe up here, the average rate of change, I might have said like of f prime on that, just so we don't confuse it, but I think because you showed the average rate of change, you should be fine, so nothing bad. All right, 2 problems to go. Function h is defined as that. Find h prime of 3. Cool. We've done a bunch of these before. We should be pretty comfortable. H prime of x equals natural logs on the outside, so it's always 1 over what was inside. But then I haven't done the derivative of what's inside, so we multiply by that, which is f prime of x. Maybe writing that a little bit more succinctly, we end up here. So h prime of 3, not bad at all. F prime of 3 divided by f of 3. F prime and f of 3. F of 3 is 7. F prime is 1/2. 1/2 over 7, and do not reduce. Oh my gosh, please don't do it. The right answer, if you reduce, is 1/14. However, it would not surprise me to see some students call this 3.5 because they screw up which fraction goes where. Just leave it there. This is the right answer. You can box it if you'd like, but that's it. All right, last part, part D. Evaluate the integral below. Well, we know there are 2 ways to evaluate an integral. Either you find the area between the curve and the x-axis. However, I'm pretty confident we don't have this graph, nor can we create it. So now it comes down to the fundamental theorem of calculus. We have a bit of an issue, though, and that issue, as I rewrite this, -3 to 2 f prime of g of x times g prime of x dx. That issue is that we have multiplication of 2 different functions containing x, and so we can't do the antiderivative. In order to do a derivative, we'd need a product rule. In order to do an antiderivative, it'd be great if there was a product rule, but there isn't one. So we need a way to rewrite this without multiplication. Now, some of you might be able to see the antiderivative, but I think this is a really nice problem to remind you of how u substitution might help you out. So, u substitution. We always want u to be the complicated piece, and we want to make sure that the derivative of whatever you choose for u also appears in the problem. So I don't want to pick u to be all of this, because the derivative of that would be way complicated. I don't want to pick u to be g prime, because the derivative of u is g double prime, that's not there. I think probably u to be g of x might be pretty good. So what if I say let u equal g of x, and I think that means then that du, the differential, is just the derivative times dx. That's pretty good as well, right? If we maybe use some colors here, we have u and then du. And I think that will strip away the multiplication of a separate function, and we should be all right. But there is one last piece we don't want to forget. We do want to change these endpoints up here. In particular, if u is g of x, then I wanted to change that -3. That's found by doing g of -3. Same thing, u of 2 is g of 2. So -3 and 2 for g. -2 and 3. So -2 became -1 and 3 became 1. And I just wrote that backwards. I got it. Okay, let's fix this. Awkward. There we go. So -2 and 3, -2 and 3. Now I've completely forgot which one was what, but g of -2 is -1 and +1. There we go. -1, +1. All right, we're back in action. Let's rewrite this integral. I can connect this with an equal sign because my new integral will be equal. We go from -1 to 1, f prime of u times du. All right, we'll keep those same colors. There's u, there's my du. All right, from here, we do the antiderivative. Antiderivative of f prime is just f of u from -1 to 1. You might want to check that really quickly. You say, well, if I take the derivative and it's not d dx anymore, my independent variable is u. So d du of f of u, then it becomes f prime of u times, well, the derivative of u is just 1 because it's with respect to u, and that does match what we started with right here. Cool. Now, because we changed the limits of integration, we can substitute those in. We don't need to replace u with what it originally equaled. F of 1 minus f of -1. 1 and -1 on f. 2 and 8. I think it was -8 though, wasn't it? Nope, +8. There we go. 2 and 8. You can stop right there. That is fine for your answer. If you're feeling bold, you can reduce to -6. So thank you for hanging out with me and going through all of these wildcard questions. Hopefully you got something out of it. Get you some good practice on the product rule, quotient rule, a lot of the chain rule, U substitution, a couple theorems, and hopefully you feel prepared because this type of free response has shown up probably 3 out of the last 5 years. So make sure you're ready.